the kids were referred to as A babies, B babies, C babies, or D babies. You may know which one you were, but the categories are really interesting. The first baby are the A babies. So these were kids that would get upset when their caretaker would leave, but when their caretaker would return, the infant would respond with happiness, with what looked like delight. They would go to the caretaker, they seemed happy. If they had been fussy before or sad, they felt relieved. These are referred to as secure attached kids. So they have a healthy response to separation and they have a healthy response to re-engaging with the caretaker. The B babies, as they're called, were less likely to seek comfort from their caregiver when the caregiver would return. So they would sometimes continue to play with their toys, or they would be with they had an adult in the room while the parent was gone. They would stay with them. It was sometimes complicated and nuanced, but these were referred to as avoidant babies. Don't run away with any conclusions about the language here just yet. It's not clear that avoidant babies become avoidant adults, but bear with me. The C babies would respond to the return of the caregiver with acts of annoyance. They seemed kind of angry, right? So it wasn't that they ignored them. They seemed kind of angry. And those were referred to as ambivalent babies. Not to be confused with A babies. These are the C babies, were the ambivalent babies. So the infant's reaction to the returning caregiver were inconsistent. It seemed like they wanted to bond with them again, but that they seemed kind of annoyed. I think we've all felt this way before, even with people that we care very much about, especially people we care very much about. And then the third category, the D babies, were the disorganized babies. That's what they called them. They weren't disorganized in that they were messy. The child avoided interactions with everyone and acted fearful when the caregiver returned. And their behavior didn't really change whether or not the caregiver was there or not. And that fourth category was actually added rather late in the course of this research. I should mention these experiments have been repeated with a huge variety of different contexts. There was work done by Mary Main at UC Berkeley and many others looking at all sorts of variations on this theme. But over time, it made it clear that certain babies are able to feel secure upon re-engaging with their caregiver, and others don't, or they're confused about it. So we probably don't know whether or not you were an A, a B, or a C, a D baby unless you were in these experiments and somehow you had that knowledge. But this work, this classic work, opened up a huge set of important questions that relate to what is the reestablishment of the bond really about? I mean, what's actually being figured out here is not whether or not there are 4 categories of babies. That's interesting. But it presumably is more interesting to focus on what is it that defines a really good bond, a secure attachment or an insecure attachment or an avoidant attachment. And the 4 things are gaze, literally eye contact, and doesn't have to be direct beaming eye contact with no blinks like people have accused me of before. It can just be gaze that, you know, people look at each other. You see couples, they look at each other. They don't always stare at each other long periods of time. Sometimes they do. Vocalizations, so what we say and how we say it. Affect or emotion, so the way that we express, you know, crying, smiling, etc. And touch. Those 4 things. And you probably could add a 5th dimension once language and written language develops, which is written word. Exchange of letters, exchange of texts, exchange of things of that sort, emails, are another way in which people can bond. But gaze, vocalization, affect, and touch are really the core of this thing that we call social bonds and emotionality. Now, that's important. We know, for instance, that there are brain areas like the fusiform face area, which is deep in the brain, that is responsible for the processing of faces. Children's recognition of their parents' faces and voices is extremely accurate and strong. Likewise, parents' recognition of their child's vocalizations, not just voices, but cries, are remarkable. If you've ever had the experience of being at a party with somebody who has small children and you're talking to them and all of a sudden they hear something but you don't, it's as if they've got wolf hearing, and all of a sudden they go running into the other room and indeed, you know, the kid is like, I don't know, some kid is beating up their kid, or their kid's beating up some other kid, or the kid has injured themselves or feels emotionally injured. This perception of voice is, there's very good evidence to support the fact that we are tuned to the frequencies of voices and vocalizations of people that we care about. It's not just true in rodents and in birds and other mammals. It's definitely true in humans as well. And babies are very tuned in to the sound of their mother's voice, even, yes, while they're in the womb. There's this whole world of what's called mother-ease, which is the particular style of speech that mothers and other caretakers now we know use with children. So those are the core elements, right? How you look at somebody and how they look at you, what you say, what they say, what they seem to be feeling, and how that makes you feel. Smiles, frowns. If you know someone really well, you can read inflections in like even little subtle things like, you know, they don't really believe me, or they're really excited by this, or you know, now I know what they're thinking. That kind of processing, some people are better at it than others, but everyone's better at doing that with people that we recognize and know. In fact, couples come to know each other exceedingly well, so much so that it can both benefit and injure their relationship to constantly be making these perceptions. But there's a range. Some people are more tuned into this than others. And that probably has roots in the sorts of attachments that you form early on. So Bowlby and colleagues developed these ABCD thing, and it has a lot to do with face processing and gaze and vocalizations and touch. All of those happened on return with the mother, but they weren't parsing those. They weren't looking at them individually. So this raises a really interesting question, which is, what is it when we feel something? Is it because of something that happens spontaneously in us? It's a memory, or it's something that we realize, we saw on the internet, or we got news about somebody. You know, nowadays people get so much information about the people they know, both the people they like and dislike, by way of viewing online activities, right? So they're exterocepting, and then it's impacting your internal state. And it's clear from most all of the theories of emotional health that an ability to recognize when your own internal state is being driven primarily by external events as important for being able to emotionally regulate, right? People who are constantly being yanked around by the external happenings in the world, you would say are emotionally labile. They are not in control of their emotions. Even if they're calm all the time, if that calmness only arrives because they're in a placid environment and then you put, a cracker in that environment and they freak out, well, then they're not really calm. They're calm insofar as there isn't something disturbing in the environment. So how much the outside environment disrupts your internal environment has everything to do with this balance of interoception and exteroception. And it very likely has roots in whether or not you were secure attached or insecure attached, disorganized or ambivalent as a baby. Of course, you can't travel back in time and know, but there are some hints as to what kind of emotionality each of us has by examining two periods of development. One is adolescence and puberty, and the other is adulthood. So while we can't travel back in time, there is an exercise that you can do to address, at least in this moment, whether or not you have a bias for exteroception or a bias for interoception. Whether or not you are better, at least in this moment, at paying attention to what's going on internally or externally. And of course, this will vary with circumstance. I think we all know people that, maybe it's you, you go to a party and you get there and everyone seems to be talking and having a really good time, and you're wondering whether or not you have any food in your teeth, or whether or not there's something on your face, or whether or not your hair is right, or whether or not you said something the wrong way, whether or not you're turning red. People also experience this a lot with public speaking. And it's not just about learning to clamp your level of stress. It's also about how much you're exterocepting, how much you're out of your head, they call it, but how much you're focused on the events around you versus the events inside you. Actually, it's interesting when you talk to people who are very effective athletes or they have very high stress, high consequence jobs, they talk about this notion of getting out of your head. You only have so much attentional resource, and it can be split between two things. You'll see that in a moment. It can be anchored to one thing. It can be fully focused on what's going on internally, or it can be fully focused on what's going on externally. And if you want to be effective in the world, effective being in quotes, it is useful when in very dynamic environments, especially social environments, to have a lot of your attention focused outward, as opposed to trying to pay attention to whether or not you're saying things correctly or the timbre of your own voice. That is more or less destructive for the ability to engage socially. So here's the exercise. You can do this. Please don't do this if you're driving. But let's just try and illustrate or allow you to experience this interoceptive, exteroceptive balance and the extent to which you can move interoception and exteroception deliberately. If you close your eyes right now and concentrate on the contact of any portion of your body with, say, the chair or your car seat, although please, again, don't do this while you're driving, anywhere that you are, even if you're just standing up or you're in the kitchen, or you're lying on the couch, and trying to bring as much of your attention to that point of contact as possible. And then from there, you're going to move your attention even more deeply into, say, the sensation of what's going on in your gut. Are you full? Are you empty? Are you hungry? Are you not? Is your heart beating? At what rate? What's the cadence of your breathing? Basically bringing your focus and attention to everything at the surface of your skin and inward. So I'm going to do a rare thing on the Huberman Lab podcast. I'm going to introduce about 5 to 8 seconds of silence in order to allow you to do that a little bit. Okay. Now, this is an exercise that you can continue afterward if you want to extend how long you do this. But now try and do something that for most people actually is a little bit harder, which is to purely exterocept. Put your eyes or your ears or both on anything in your immediate space, one thing. And I would restrict that thing to something small enough that at least in your field of view, it would occupy, 20% of your field of view. So it doesn't have to be a pinpoint unless the pin is right in front of you and you're holding it real close. I would say look across the room, pick a panel on the wall or a leg of a table or something, and try and bring as much of your attention to that as possible. And again, I'll take about 5 seconds of silence to allow you to exterocept. Okay, so what you probably found is that you were able to do that, but that some degree of interoception is maintained. It's hard to place 100% of your attention on something externally unless it's really exciting, really novel. If you've ever watched a really great movie, presumably you're exterocepting more than you're interocepting until something exciting happens, and then you feel something. You're actually tethering your emotional experience to something external. And now you can also do this dynamically. You can decide to focus internally and then externally. You can decide to split it 50%, or 70-30. You can develop a heightened ability to do this. And the power of doing that is actually that when you are in environments where you feel like you're focused too much internally and you'd like to be focused more externally, you can actually do that deliberately. But as you notice, it takes work. It involves taking your attentional spotlight and what we call the aperture of your attention and narrowing that aperture to either the self or something externally or splitting the two. And yet there are practices that have been developed that center on moving interoception and exteroception from one being more heavily weighted than the other, more focused outward or more focused inward. And it's dynamic. And the circuits in the brain that underlie intero and exteroception aren't exactly known, but they are anchored in the areas of the brain that are involved in attention, like the frontal eye fields and areas that when you third person yourself, when you can see yourself doing something, like if you put your hand out in your environment and you focus on your hand, you know that that's your hand as opposed to some random object. There are areas of the brain that are involved in that, in recognizing location of self relative to the rest of your body. These exercises are really what are at the core of these development of emotional bonds, because as we mentioned before, these four things, the gaze, vocalization, touch, and affect, those are happening very dynamically. So if somebody winks at you, you're paying attention to their wink, but then you also notice how you feel. Then they might say something.
There we go.
You might say something. This is very dynamic. So if it seems overwhelming to try and interocept and exterocept and then shift the balance, you do that all the time. Your brain and nervous system are fantastic at doing this. Now, some people have a very hard time breaking out of a very strongly interoceptive mode. Some people have a harder time breaking out of their exteroceptive mode. It's very interesting to note the extent to which we have biases in how interoceptive or exteroceptive we are. Remember those three axes that we talked about earlier. You have valence, good or bad. You have alertness, alert or calm, and you have interoceptive or exteroceptive bias, right? And it's going to differ across the day. It's going to differ across the lifetime. It's certainly going to differ according to whatever it is that you're engaged in. But early in development, you start off with this interoceptive bias. You are starting to develop expectations, predictions about how the outside world is going to work. And you are trying to figure out the reliability of outside events and people. And where things are reliable, when people are reliable, we are able to give up more of our interoception. There's literally trust that our interoceptive needs, our internal needs, will be met through bonds and actions of others. And this starts to veer toward the discussion about neglect and trauma. We are going to devote entire episodes, probably an entire month, to trauma and PTSD. But those have roots in what we're talking about now. And it's important to internalize and understand what we're talking about now in order to get the most out of those future conversations. So if all of this seems like a lot of information and very complicated, I just invite you to pay attention from time to time how much you happen to be interocepting or exterocepting, because emotions and the intensity of those emotions will grow or shrink depending on how much we're interocepting. If we are feeling extremely sad and there's an outside event that made us sad, chances are there's going to be a balance, but that the extreme grief, the extreme sadness is going to lead us to mostly interocept. Whereas when we're feeling extremely happy, the same is true. something great happens in the world, and we're just going to feel it. Most of our perception, most of our awareness is going to be on an internal state. So we are always tethered to the outside world to some degree or another. That was true when you were an infant, and it was true when you were an adolescent, and it's true as an adult. So now I want to just pause, just shelve the discussion about interoception, exteroception for a moment, and I want to talk about what is arguably the second most, if not equally important, aspect of your development as it relates to emotionality and as it relates to this, what I call trust, but this ability to predict whether or not things in the outside world are reliable or not reliable in terms of their ability to help you meet your interoceptive needs. And that period is puberty. So up until now, we've been talking mainly about psychology, not a lot of biology, not a lot of mechanism. And now we're going to transition into talking about mechanism, hormones, receptors, etc. Puberty is a absolute biological event. It has a beginning and it has a specific definition, which is the transition into reproductive maturity. So there are a lot of hormonal changes. Yes, there are also a lot of brain changes. And most people don't realize it, but the brain changes occur first. The brain turns on the hormone systems that allow puberty to occur. Puberty is occurring earlier nowadays than it did in the past. The current numbers that I was able to find is that in females and girls, the transition is starting around age 10, whereas in boys, it's about age 12. That's going to differ by way of a number of different factors. Those are averages. So it depends on where you are in the world, depends on all sorts of things. One of the primary triggers for puberty is actually body fat. This is interesting. The peptide hormone, leptin, some people call it a peptide, some people call it a hormone, but it meets both definitions depending on how you look at it, is made by fat. So leptin had a lot of popularity in the 90s because it was discovered as being produced by fat, and it was seen in animal studies that it could promote leanness. It actually communicates to the brain that there's enough body fat in order to allow the metabolic factors and processes to occur to liberate more fat. This is why people have trouble losing that last 5 pounds. It's because leptin levels are very low. This was actually the basis for the whole cheat day refeed thing, that the idea was if you eat a lot for 1 day a week while dieting hard, that you can signal to the brain that there's enough leptin. I don't know if that's the reason or whether or not the cheat days just provided some psychological relief, probably both. But in any case, leptin is made by body fat, and when there's enough leptin, it signals the brain to trigger puberty. There was a paper published in the mid-90s in the journal Science, excellent journal, showing that leptin could be injected into younger females that would not have yet gone into puberty, and you could accelerate the onset of puberty with leptin. So the more body fat, the earlier puberty. That's true. Leptin is also involved in various growth effects in the body generally. And it's interesting, very obese children don't necessarily undergo puberty earlier. Sometimes they do, but they do tend to be larger boned. Their bones actually grow more quickly, and they tend to have higher bone density because leptin is also involved in bone density. The whole issue of onset of puberty also has some really interesting social effects. And I want to really highlight that most of these effects are so-called pheromone effects. Remember, a hormone is a substance secreted from one area of the body, travels and impacts tissues and cells elsewhere in the body. A pheromone is a chemical that's released by one member of a species that goes and acts on and impacts other members of that species or even other species. So, for instance, rodents are very good at detecting the urine and the scent markings of large carnivores that want to eat them. So that's a pheromonal interaction. Whether or not there are pheromonal effects in humans is very debated. I did a post on this on Instagram a little while ago about some pheromone effects that were reported in humans, and I had a couple of people come at me saying, look, it's never really been shown in humans that there's a pheromonal, what's called the vomeronasal organ. There's something called Jacobson's organ. It's rudimentary. Some people have it, some people don't. Very controversial. So I want to point out that human pheromone effects are controversial, although I think there's, in my opinion, there's ample evidence for them. Synchronization of menstrual cycles, for many people report Then people say there's some studies that show that it's not true. Then there have been some data showing very impressive pheromonal effects of female partners being able to detect the odor of their significant others on T-shirts that were washed several times, so they can't consciously perceive it, but they say this one smells like them, this one smells like my partner. And indeed, the match was way above chance. So there does seem to be weak pheromonal effects, at least in my opinion, when I look at the data, but much more needs to be done. So one of the more interesting pheromone effects that impacts puberty, at least in animal models, is the so-called Vandenberg effect, which is if you take a pre-pubertal female, so a female that has not undergone sexual maturation, and you introduce a novel male that is not the father or a brother, not a sibling, she will undergo puberty almost immediately. So this is really striking. For years, this was thought not to occur in primate species, but there was a paper published last year in Current Biology, Cell Press Journal, excellent journal, showing that mandrills, a particular type of primate, they exhibit this Vandenberg effect. There are also all sorts of other pheromone effects. There's the most infamous one is called the Bruce effect, where the introduction of a novel male to a pregnant female animal causes spontaneous miscarriage. And that effect seems to be protected against by the presence of the father. So another, the interpretation of this, and I want to really highlight that these are animal studies, but the way this works is that if a pregnant female is in the company of the male that impregnated her, then her young are protected by his scent presence or his pheromone presence. But if he's gone and a novel male shows up, there's a tendency for her to spontaneously miscarry and essentially for the fetus to be lost. Now, whether or not this occurs in humans is still very controversial, but nonetheless, these pheromone effects exist. And that one is called the Bruce effect, named after Hilda Bruce, who is the scientist that discovered it. The one that's relevant to the puberty discussion is the Vandenberg effect, which I mentioned a few minutes ago, which is a novel male showing up. It has to be a sexually competent male, so he has to have already passed through puberty. And his presence triggers activation of puberty in a female that otherwise would have remained prepubertal for longer. Again, whether or not this happens in humans, unclear. Well, what can we be sure about when we think about puberty? Puberty is triggered by a number of different factors. There are changes in GABA expression in the brain, an inhibitory transmitter. One of the more interesting molecules that triggers puberty in all individuals is something called kisspeptin, K-I-S-S-P-E-P-T-I-N, kisspeptin. Kisspeptin is made by the brain, and it stimulates large amounts of a different hormone called GnRH, gonadotropin-releasing hormone, to be released. Gonadotropin-releasing hormone then causes the release of another hormone called luteinizing hormone, or LH, which travels in the bloodstream and stimulates the ovaries of females to produce estrogen and the testes of males to produce testosterone. Kisspeptin has other effects as well, but those are some of the main ones as they relate to puberty. Now, this is interesting because at this point, the testes in males start churning out tons of testosterone in order to trigger the development of secondary sexual characteristics, body hair and all the others, deepening of voice, etc. And in females, estrogen is doing various other things, breast development, etc. Normally, in an adult, somebody who has passed puberty, a big increase in gonadotropin-releasing hormone and luteinizing hormone would eventually be shut down because the way that the brain works, the hypothalamus and the pituitary are actually measuring how much hormone is in the blood. And if testosterone or estrogen or any other hormone goes too high, they shut down the release of things like luteinizing hormone. It's called a negative feedback loop. It basically is like a thermostat in a house. It's more complicated than that. But once levels get too high in the bloodstream, it shuts down. But kisspeptin is able to drive very high levels of these hormones in an ongoing way so that puberty can commence and can continue. And incidentally, kisspeptin has now become yet another of the panoply of hormones and peptides and cocktails that athletes take in order to try and stimulate natural hormone production, essentially to create their own performance-enhancing drugs endogenously. No judgment there, but that's a fact. There's a lot of kisspeptin use. People, I'm truly not suggesting anyone do this, but people are buying and injecting kisspeptin for the specific reason that even past puberty can stimulate the large increases in things like estrogen, large increases in testosterone and things of that sort. Has a number of psychological effects too. Seems to have big effects on libido, etc. All these things, of course, are subject to feedback loops. So they don't work indefinitely. And I'm going to highlight, again, I'm not suggesting anyone do it, but I do like to pay attention to what's out there. And kisspeptin, because it wasn't discovered that long ago, is one of the things that you don't often hear about when people talk about performance-enhancing drugs or therapeutic endocrinology. These things also have therapeutic uses in the endocrine setting. So, for instance, kids that don't undergo puberty or kids that are hypogonadal or adults that are hypogonadal, they're not making enough hormone, will take things like kisspeptin, among other things. So that's how puberty happens at the biological level, gets triggered by leptin and kisspeptin. And then this young child is now a different creature to some extent, not just because they're reproductively competent, of course, but because there's a shift in a number of the things that underlie these social bonds. There's a marked shift in a number of the things that allow children and adults to engage in predictive behavior about each other. And the whole nature of adolescence and puberty is to take a child that was a generalist and to make them a specialist. And this is very important as it relates to the conversation about emotionality. But it's important in terms of all aspects of brain function and in terms of learning and in terms of who each and every one of us will and has become. In adolescence and in childhood, sure, there are some genetic biases, hair color, eye color, height, and things like that. A lot of that's programmed into the genome.
What up, Huberman?
there are other genetic biases too, of course, that we inherit. But it's in adolescence and puberty that we go from essentially being somewhat good at a bunch of things or somewhat poor at a bunch of things to becoming very good at a few things and very poor at a lot of other things. And that's because of the relationship to puberty and neuroplasticity. This ability to change the brain in response to experience is starting to taper off such that by our early 20s, it's harder to achieve. Now, the transition from generalist to specialist is one aspect of adolescence and puberty, but the other is the formation of social and emotional bonds. And most of what consumes the minds and waking hours of adolescents and children who have gone through puberty and going through puberty is questions about how they relate to social structures, who they can rely on, and how they can make reliable predictions in the world now that they have more agency, that they are physically changed. In fact, you could argue that puberty is the fastest rate of maturation that you'll go through at any point in your life. It's the largest change that you'll go through at any point in your life in terms of who you are, because your biology is fundamentally changed at the level of your brain and your bodily organs, all your organs, from the skin inward. So I want to visit a little bit of the research about some of the core needs that occur during puberty and adolescence, not just for parents or for the people that might be in puberty and adolescence, but also so that people can reflect on which of these sort of boxes were checked off for them as they approached emotional maturity. So there's a terrific review article that was published in the journal Nature, which is, if not the premier, then certainly among the top 3 premier journals in the field of science, about the biology of adolescence and puberty, as well as some of the core needs and demands that have to be met for successful emotional maturation during that time. We will provide a link to that, but I just want to highlight a few of the things that they place in the final table. I don't want to go through all the results right now because you could do that on your own if you like. They mainly highlight a lot of the changes in neurons and neural circuits. For instance, I'll just highlight one. There's a connection between the dopamine centers in the brain and an area of the brain that's involved in emotion and dispersal. Dispersal is very interesting. What you observe in animals and humans is that around the end of adolescence and during the transition to puberty, both because of changes in the brain and changes in hormones, there's an intense desire on the part of the child to get further and further away from primary caregivers. Not permanently. They always return, similar to a child that walks off and then looks back and sees if everything's safe and then continues on. During adolescence and puberty, both in animals and in kids, it almost seems like there's a bias for action, and the action is always in a direction away from the primary caregiver. Now, as soon as I say that, I can just imagine in my mind that somebody out there saying, well, no, my kid, as soon as they hit puberty, they just want to stay home with us all the time. That's not typical. It happens, but it's not typical. Mostly there's a desire to start spending more time with friends, more time with peers, and less time with adults. And I find it extremely interesting to note that that's not just true in humans. That's true in other primate species. That's true in rodents. That's true in almost every other mammalian species. So there's something about these hormones that don't just allow sexual reproduction. They don't just change the brain and bodily organs and the shape of us. They also bias us towards dispersal, getting further and further away from primary caregivers in particular. So parents of teenagers or future teenagers, it is not just normal. It is baked in to the biology of humans to disperse around adolescence and in the teen years. So again, I just want to highlight a few of these, what were listed as intervention strategies to promote healthy adolescence and puberty. And it's very interesting because the entire article, and I should mention who wrote this article, apologies. One of them is a friend of mine. So the first author is Ronald Dahl, not the children's book author, I'm assuming. No, from the School of Public Health at University of California, Berkeley. And Nicholas Allen, Linda Wilbricht, and Anna Ballenhoff-Suleiman, forgive me for the pronunciation of the last one. I know Dr. Wilbrick quite well. She's done the work on dispersal, is quite well known for that work. And it's a very extensive review, but I think you can find it. You'll find it accessible. A lot of changes in thickness of the brain at different stages, et cetera. But I think most people will be interested in what that translates to in the real world. And what's interesting is during puberty, there's increased connectivity, as we call it, between the prefrontal cortex, which is involved in motivation and decision making, being able to suppress action for making long-term goals possible, as well as dopamine centers and the amygdala. So there's this really broad integration and testing. I think this is the key element here. Testing of circuits for emotions and reward as they relate to decisions. And I think that's useful because when you look at the behavior of adolescents and teens, they are testing social interactions. They are testing physical interactions with the world. Oftentimes they're engaging in unsafe behavior. And you can't I would never try and justify that with the underlying neurology. But the neuroscience points to increased connectivity between areas of the brain that are related to emotionality and to threat detection, like the amygdala, but also reward. So it's a time of testing behaviorally how different behaviors lead to success or not. It's how different behaviors lead to fear states or not. Now, of course, you could say that of any stage of development, but it seems like puberty is a very, very heightened stage in which testing of contingencies, good or bad, is taking place. And of course, this is happening. It's operating in a body that's now more capable than the infant. So an infant can damage themselves through error, but it's harder for them to damage themselves through deliberate planning. You know, that's why it's important, of course, to lock up all the medications in the house, make sure infants can't get to them. But it's not likely that the infant is going to devise an extremely diabolical plan to get into the cabinet to get a certain substance, whereas a teenager might, right? So you can start to map the neurology onto some of this emotional exploration. I do realize that this episode is about emotions. Puberty is a time in which the internal state of the person or the animal is being sampled and tested against different exteroceptive events, only now they are able to guide those events with more agency, right? It's no longer just about whether or not the caregiver is bringing you milk or bringing you food. Now, of course, the parents will all say, yeah, but I'm paying for everything that they're doing. I'm paying for the car and I'm paying for the food. True, but the biology doesn't care about the source. The child or the adolescent is now able, the teen really, is able to now sample many, many more exteroceptive events through behavior. So some of these recommendations are interesting. The theory is that one of the motivations is to learn to mitigate the risk of famine and malnutrition. As teenagers get older, they start questioning whether or not their parents are everything they thought they were, whether or not they're the greatest thing that ever was, or the worst thing that ever was, perhaps, including whether or not they will be able to provide them resources. So they test whether or not they can actually feed themselves, whether or not they can support themselves. Although rarely, certainly it happens, but rarely are they really taking care of themselves, although some teens are forced to take care of themselves, of course, because parents and other caretakers aren't available. The recommendations that map to the biology include there's been a big push for later start times in schools to match their shifts in circadian rhythms and the need for extended sleep, something we talked about during the sleep episodes, to insist on sleep interventions for youth who are at increased risk for mental health problems. Almost every mental health issue is supported by getting regular quality sleep of sufficient duration. Sufficient duration is going to vary from person to person. Leveraging different kinds of social relationships that reinforce positive behavior. This is starting to sound like kind of a boilerplate stuff. And yet, really the goal is during puberty to encourage as many safe forms of interaction that allow children, teens really, and adolescents, I keep calling them children, but what I mean are children going through puberty, that allow them to test this thing of autonomy so that they can start to make good assessments about their exteroceptive events that they are selecting and how those make them feel internally. So they're essentially doing a buffet. The buffet has now broadened to not just include the events and experiences that their parents and other caretakers bring them, but they can now expand the buffet into things that they can provide themselves. And so adolescence and puberty is really seen as the period of development in which one self-samples for these two elements that we talked about at the beginning, which are how do I form bonds and how do I make predictions about what will make me feel good at a level of interoception. Some of that might sound a little transactional, that all we're trying to do is figure out how we can bond with people so we can get what we need, so we can feel how we need. I think that's true to some extent. Of course, there's a richer, more abstract aspect to relationships too, which are, in relationships you can access things you couldn't do before. You can cooperate. There's things like teamwork. You can do all sorts of things. But in terms of the biology, it's clear that there's this stage of development where more autonomy, more physical capability is triggered by these hormone changes in the brain and these peptide changes in the brain and body. And that nonetheless brings us back to the exact same model that we started with in infancy of alert or calm, feel good or feel bad, primarily exterocepting, primarily interocepting. So I keep going back to this. I'm sort of like a repeating record on that because the same core algorithm, the same core function is at play throughout the lifespan. And that's a useful framework, in my opinion, because it allows you to sort through all the data and information that's out there about, well, this area, the stria terminalis is active, or the basolateral amygdala is active, or gray matter thickening, or this hormone or that hormone, and return to a kind of kernel of certainly not exhaustive truth. It doesn't cover all aspects of emotionality, but at least establishes some groundwork from which you can start to evaluate how different behaviors might or might not make sense, how certain emotional responses might or might not make sense, regardless of the age of the person or the organism. A discussion about emotions would not be complete without talking about the right brain, left brain stuff. And this is a very interesting aspect of sociology, psychology, and neuroscience. There's a theory of emotional development that I find particularly interesting, which is from Alan Shore at UCLA, that talks about how most of our testing of bonds and relationships is this seesawing back and forth between very dopaminergic, so driven by dopamine, or serotonergic, driven by serotonin, states. And this starts with infant and mother, or infant and father. I talked a little bit about this in the previous episode, but just to remind you, or for anyone that didn't hear about it, that during development, healthy emotional development clearly begins with an ability for the caretaker and child to be in calm, peaceful, soothing, touch-oriented, eye-gazing type of behaviors. Those really drive serotonin, the endogenous opioid system, oxytocin, things that are very calming and are centered around pleasure with the here and now, as well as excited states of what we're going to do next. There's actually a kind of characteristic sign of the dopaminergic interaction where both caretaker and child are wide-eyed, the pupils dilate, that's a signature of arousal. They get really excited. Oftentimes the baby will look away if it gets really excited. Those are signatures of dopamine release in the body. And in adolescence, these same things carry forward, where their good bonds are achieved through hanging around, watching TV, just kind of being, or playing video games, or texting together, or talking, whatever it is that the soothing local activity happens to be, as well as adventure and things that are exciting. So it could be sports, it could be shopping, it could be summer adventure, it could be the next big thing. And so this kind of seesawing back and forth between the different reward systems seems to be the basis from which healthy emotional bonds are created. And I invite anyone who's interested in this to look up some of Dr. Shore's work. I think I misspoke on the last episode. He's not a psychiatrist. He's a clinical psychologist and psychoanalyst, but has deep rootings in neuroscience. So it's, I think, a fascinating aspect. But the way it's framed in that book and in his book and in some of the language around that is around right brain, left brain. And we've all heard this stuff before, that the right brain is thought to be the emotional side. This is the characteristic thing that you hear out there. that the right brain is holistic, that it's emotive, and that the left brain is logical, sequential, and analytic. And that's not what Shore was proposing. There are some right brain, left brain differences, but the idea that the right brain is synthetic, holistic, and emotive, and that the left brain is logical, sequential, and analytic is false. There is zero neuroscience evidence for that whatsoever. We're going to address this in more detail during a month talking about learning and memory and dementia, but let's talk about some truths, some differences between the left brain and right brain, because we can't have a discussion about emotion without doing that. The left brain, at least for people who are right-handed, is linguistically dominant, meaning most of language is centered in the left side of the brain for right-handed people. If you were a left-hander and you were forced to become right-handed, chances are this is still true because of when language gets laid down in the brain. For left-handers, people that naturally write with their left hand and always did, language is still mostly in the left side of the brain, but it's also found more often in the right side of the brain. So it's not as lateralized as we say. It's kind of distributed between both. Okay, so right-handers, most of your language is coming from the left side of your brain. Left-handers, it's probably a little bit more evenly distributed. And there are some variations, whether or not you're a hook righty or a hook lefty. There's all sorts of nuance to this, but that's the general aspect. So language tends to be centered in the left side of the brain. And that includes lexicon, grammar, syntax, all of it, except for one. And we'll talk about one aspect of language that seems to be more right brain that's very interesting. There does seem to be some arithmetic advantage, so ability in math, in the left side of the brain. And I'm going to talk about how all this was discovered in a minute. And the right brain, however, is linguistically primitive. Most people don't realize this because the right brain is always described as the emotive side. It's super emotional and holistic, but it's actually linguistically primitive. And there's a way that's been teased out through experiment. It's very good at manipulating spatial things and visual spatial tasks. It's primarily handling that stuff, but it's sort of non-language, except one aspect. And there isn't a ton of evidence for this, but the evidence is strong, which is prosody. Prosody is the lilting and falling of language. So a good example would be Italian. I don't speak Italian. I only know a little bit of Italian. But most of the Italian I know is when my Italian colleagues have said to me, "Ma cosa dici?" which means like, "What are you trying to say?" or "What are you saying?" I think I'm getting that right. Basically, they're saying I don't speak Italian, which is true. Or because one of them knows and loves Costello very much, they always say "un pigrone," which means big lazy guy, which accurately captures Costello. So even those few examples, right? "Ma cosa dici?" "Un pigrone." There's a lot of lilt and fall in Italian. Other languages, not so much, and it varies by language. One of the reasons I find Italian so beautiful, not the Italian I speak, but the Italian that other people speak, so beautiful to listen to is that prosody and the shifts in intonation are really quite remarkable. It's almost like a sing-song listening to them speak. And I used to like to go to scientific meetings, and I always hang out with the Italians because I have some good friends in Italian labs, but also because they always knew where the best food was. Their standards for food are incredible. They would rather starve than eat terrible pasta, and the pasta they do find and that they're willing to eat is always fantastic. But in addition to that, they always brought a guitar. They were a lot more fun than a lot of my other colleagues to hang out with at meetings. So in any event, the right brain is doing things that are more about manipulating spatial information. And I'll talk about this more in a future episode, but this was discovered in split brain patients, so people that lack connection between the two sides of the brain. And this had to be teased out through very complicated experiments. People like Roger Sperry, who won a Nobel Prize for this, who was at Caltech, Mike Gazzaniga, and others, figured out these lateralized differences. But let's just try and demolish the myth that, that the right side is synthetic and holistic and emotive, and that the left side is logical, sequential, and analytic, that you're a left brain person or a right brain person. Nothing could be further from the truth. There's no scientific evidence to support that. And there's a few lesion studies that can tease out effects that make you think that's what's happening, but the really careful work points in a totally different direction. We can't have a complete conversation about emotions and bonds and social connection without talking about oxytocin. Oxytocin has come to such prominence in the last decade or so and seems to be everywhere. Anytime you hear a discussion about neuroscience in the brain,